All right, so I want to continue on here. Now let me get a share screen going. So I left off talking about the lighting window. The lighting window, uh, which is a dockable window. Let me stop that. So we get the lighting window, the lighting settings, and I mentioned the Light Explorer, and I've docked these down here, and we can see their different properties. The controls of the lighting window have basically 3 tabs. The scene tab is where all the different settings are applied. And the other 2 tabs are the real-time light maps that are generated by the real-time GI and the baked light maps that show the light maps for baked GI. So here in this scene, I have the mixed and light in here, and under lighting, there are no, well, there's a real-time map because it's mixed, and the baked light maps are here. You remember I mentioned the indirect light is cast into the scene. This is basically the plane here that we're seeing where the red light appears. In a real-time scene, there's a real-time scene. Let's see, under lighting. Now under real-time light maps, I have that same baked stuff. The difference being that real-time is going to allow us to change the lights and do other stuff. This time there's no baked lighting. So those are the tabs that we see in the lighting window. I've mentioned a couple times this issue of the check mark here. The real-time lighting is turned on with this. The baked and or mixed lighting is turned on with this. And if I have auto generate checked, every time I move something in the world, it will update those light maps. Now, it doesn't do the whole bake. It's pretty smart, and it only updates that which moves, but it is still a computational load. And so generally, I let the generate lighting proceed here. The generate lighting is going to produce these folders that have the same name as your scene, that contain the light map information. These are textures that you can actually look at some of these textures, the light map data, the reflection probe, other things that are included in here are in these folders that are generated. If, on the other hand, you're using auto-generate, the global illumination goes into a GI cache, and later when we start switching among scenes, it's best not to have that information in the GI cache. It's best to have it in the compiled game that you're going to produce. So I recommend manually generating the lighting for any scene when you're completely done with it. You can leave auto-generate on while you're doing it if your computer will support it, but generally that's the auto is not a great idea. This little pull down lets you clear all of the baked data. This would make you start from scratch. So if things look wonky, you can always flush that and start over again. So we can clear the cache, and there's the auto generate. With the exception of the real time, if you do generate a light map for the baked, it'll show you some kind of progress bar that's going on in here. For some reason in my version, that progress bar has disappeared for real-time lighting. I'm not sure why. Now, the other window I mentioned was the Light Explorer. This helps to manage various lights within your scene. The Light Explorer has all of the different lights. There aren't very many in this scene. There's just the one directional light, this directional light. And we can turn it on and off here in the Light Explorer. We can change its color. We can change its intensity. And because this is real time, changing its intensity will change what happens within the scene, and changing its color, so forth, will update within the scene. The other thing that we see in the Light Explorer are reflection probes, light probes. I don't have either of these in this scene, as well as the static emissives. These are the objects, the emissive materials that have to be baked in order to appear in the scene. They have to be set to light map static or contribute GI in order to appear here. But if I had a material that was emissive, it would appear in this slot too. So this is a handy tool to have in your scene. One of the other things that appears here is the indirect multiplier in the light. This is how much more intense that bounce lighting is. And for demonstration purposes, I have this set up to 4, which means the indirect light is 4 times as bright as it would be if you did a physically based bounce. If I set this back to 1, notice, because we're in real time, that lighting, that red hue that was the bounce light off the red object, became much less intense. It's still there, but it's much less intense. And I turned it up here, and it takes a minute for it to propagate into the scene. So the Light Explorer is a handy tool that lets you see all the different lights and their properties without having to dig through your hierarchy view to find and modify them. So it can. It also has the mode. This is a real-time light, but we also have mixed lights that are kind of a combination of mixed and baked lights that are purely baked lights. I'll show you examples of these in more detail later. The indirect multiplier varies the intensity of the indirect light. It's a multiple of the default brightness that's calculated. 1 is the default. You can make it brighter if you want to, or you can actually set it to 0, in which case the bounce intensity disappears and it no longer looks like pre-computed real-time GI. You can do this for an individual light. As I mentioned, the main property that we must specify for various renderers and terrains is that they be light map static, or in newer versions contribute GI. And once we do that, that object's location is fixed and it can no longer participate, it cannot move. Now, we still want to be able to light objects that we want to be able to move. For instance, our character. If you remember back to LERPs and when we were playing with lights, I showed you a situation with emissive light where it was cast on the world, the terrain, and other objects, but it wasn't cast onto LERPs, the character. And that was because LERPs, to be able to move, could not be light map static. And for these, we need to light them with light probes. So um, and I'll show you an example of a light probe somewhere here. Light probes, I'll show you this example in a minute. The other feature that's defined in the lighting settings is the skybox, the thing that surrounds our world. And so this is up at the top here where we specify the skybox material. Uh, um, the skybox materials can be quite varied. Here are different skyboxes. Um, uh, uh, these are all different skyboxes that have different effects on our world. Uh, These are all the different skyboxes. Here's the default skybox. This is the one that you can set the sun to move in the sky by turning the light. A very cool trick. Uh, uh, but I'll come back and show you more details in this in a little while. The other feature is reflection probes with very shiny materials. These are materials that are very metallic. We'll talk about materials later. They can reflect the world, and a shiny material by default will reflect the skybox. But if you wanted to reflect objects that are in your world, you need to place reflection probes around your world. And these reflection probes behave like a six-sided camera that takes photos left, right, up, down, forward, and back. And like the skybox, can be imposed on a shiny object so that it looks reflective. And I believe I have a scene here with reflective shiny objects. So here's a shiny object. Uh, uh, I've got this reflective ball that I can turn around in the world, and it's reflecting the environment. The only reason that I can see these objects is that there is a camera taking these pictures that are then imposed on that shiny object. So I mentioned the toggles for turning on real-time and mixed or baked pre-computations. Your various lights have to be declared to be either real-time, mixed, or baked. The light map settings also include the resolution in pixels per unit, how many uh, uh, texture objects per unit length per meter are based on our object. The indirect lighting is all very fuzzy, so we don't have to make them very big. There's a choice of what light mapper to use. Real-time uses Enlighten. That's the one that's been deprecated. And there are two other light mappers, the progressive CPU and the experimental progressive GPU that do baked lighting. There are also settings for fog, halo, flares, cookies, and other things. The scene view over here has various settings for our objects. Uh, uh, Here in the scene view, I can focus in on the world here, and I can. I'm in a real time, so I can look at just the indirect lighting that appears in that scene. So this has turned off all the albedo and the direct lighting effects, and we're only seeing the indirect lighting. And there are various versions that we can look at. We can look at emissive light, directionality, and some other stuff. If we were in a baked scene, we would these would be available, which would let us also see the various properties of the baked lighting. And of course, there's wireframe and the standard shaded that is the way we usually look at the world. Here's some examples. One is the UV charts. These squares are kind of a measure of how what the resolution is of our indirect lighting. This is one of the things that one adjusts. The bigger the squares, the faster it bakes. The smaller the squares, the higher the resolution of our indirect lighting. The lighting is divided up into systems. This is to allow multi-threading, to take advantage of your CPU. There's not a lot of control over the systems. They're kind of generated internally. There's an albedo setting. These are basically the textures. If we have an emissive object, this is the emissive view. The indirect lighting, this is the bounce lighting that we're seeing in a scene. Directionality is what the normals of our different objects are. In a baked light, this is going to be the baked light that is applied to our scene. So I will come back and show you those sample programs in a minute in separate videos. So I'm going to stop the sharing here at this point, and I'm going to end the recording, and I'll see you all in class. Bye.